Okay, welcome back. Okay, now we're going to discuss population growth rate. So here's definition number 2. It says that if capital P of T is the number of entities present in a population, the population growth rate of P of T is defined as P prime of T. So it's the derivative. Again, instantaneous rate of change of a population is what we're going to call the population growth rate. Okay, so let's do an example. So, it says the population of a city is tripling every 5 years. So, population triples every 5 years. All right, what else does it say? It says if the current population is 10,000. So, P of 0, so again, T equal to 0, so present current population, again, we're starting, always assuming that T equal to 0 is equal to 10,000. Okay, good. It says, what will be the approximate, okay, key, approximate population 2 years from now? So, guess what? This is where we're going to use what we were talking about at the very beginning, okay? So we know, we want to know, let's see, what the approximate population 2 years. So we want to know what is P of 2, right? So we want to approximate P of 2. So what are we going to do? Well, we know P of 2 is going to be approximately equal to what? P of 0, right, plus H times P prime of what? Oh, hold on a second. Yeah. Yeah, exactly. So it's going to be P prime of 0, right? Because we're starting at the starting point, right? So what do we get? Now here's the thing. We can't use this one because we don't know the function, right? So we can't use this approximation. Well, that's okay. What else can we use? Well, what else can we use as an approximation? Well, actually, let me see. Yes, we can. Wait a minute. Triples every 5 years. Can we use that information? There's a piece of information we could use. What does that mean? If it triples every 5 years, doesn't that tell us something about the growth rate? So we can approximate this growth rate, right? So what do we know? Well, we know that it triples every 5 years, so let's do this. Let's approximate P prime of 0. How do we do that? Well, the difference quotient, right? So it would be F of, no, not F, P of 5, right? Since we know it triples every 5 years, let's just use that fact. So P of 5 minus P of 0 over 5 minus 0. Now, since we know P of 0 is 10,000 and it triples every 5 years, well then that tells us that after 5 years we're going to have 30,000 minus 10,000 over 5. And so now we can approximate so what's it going to be? 20,000 divided by 5, right? Okay, well, we can divide by 10 and then double it, right? So 30 minus 10 is 20, so 20,000 divided by 10 is 2,000. If we double it, it's 4,000. So this is going to be 4,000. Again, you could use your calculator, and I like using my brain, okay? So that is the approximate value of the growth rate. Okay. Now, okay, I guess that's all we need, right? So what is P of 2? It's going to be approximately equal to P of 0, which is going to be 10,000 plus H. What's H? What's the difference? That's 2, right? That's the distance, right? So in this case, we're dealing with time. So this is going to be 2. Okay? So in this case, H represents the amount of time lapse, right? In this case, 2 years. Times 4,000. So the approximate population is going to be what? 18,000. And that's it. All right. Good job. Have a great day.